started according to my watch. Anyway, my name is Nino Franco, I'm the new monitor here today, I'll explain the rules. I wanna welcome these students for thank you for coming here and making this presentation today. I will tell you the rules, and after that I'll allow the judges to introduce themselves. Then after that, you have 15 minutes to make your presentation. And I will give you a warning, I'll hold up 2 fingers, that means you got 2 fingers, 2 minutes and 15 minutes left to go. Then the judges will have 10 minutes to make up questions and answers. Then you have 5 minutes for cleanup. So at this time, I would like the judges to introduce themselves.
My name is Sean Oatman. I work for HDR Engineering in Omaha. I graduated from Iowa State University, degree in civil engineering. I've been in the civil engineering field for about 20 years, and I've worked on a pretty wide variety of projects.
Hi, my name is Leanne Zitlow. I got my civil engineering degree from University of Nebraska. I'm also with HDR. I'm currently in the water and wastewater group here at HDR.
My name is Pat Engelbert. I also work at HDR with these 2 fine folks to my left. I got my degree in civil engineering from the University of Nebraska, and I've been working at HDR for over 20 years. Do a lot of work with dams and levees and floodplains, things like that.
I'm John Remus, and I don't work for HDR. I'm the chief of the hydrologic engineering branch of the U.S. Army Corps of Engineers here in town. Water resources engineering is what I do, dams, levees, navigation projects. I worked on projects all over the world. I just got back from Southeast Asia about 3 weeks ago. So.
Okay, your 15 minutes begins now. Go ahead and start your presentation, please.
We are the Waterfalls from McMillan Magnet Center. We are the only OPS middle school out of 12 that has no signage outside of our school. Our problem right now is in the winter, we are using ice melt, which goes down our parking lot runoff and is causing the grass above to die. Our main goal for this project is to create a waterfall using the parking lot runoff to beautify the front lawn. In so doing this, we are going to need to filter the water because there's a lot of chemicals by this ice melt. It will run through pipes, which goes to rocks, in which the water will flow down and end in a 10 by 6.5 collection area.
We went through several ideas and finally agreed on creating a waterfall. Our waterfall will have 2 linear falls, because exceeding this would mean going over our allotted amount of 1,000 gallons of water. Our top rock will be raised 3 feet from the ground and has an area of 3 feet. From rock 1 to rock 2 is a drop of 1 foot, and rock 2 has an area of 1.5 feet. Rock 2 to our collection area has a drop of 2 feet, and our collection area is a 10 foot by 6.5 feet by 2 feet. We had to make our depth 2 feet because if it was any deeper by Omaha law, we would need a 6-foot fence surrounding. The rocks we chose to use were limestone and flagstone. We chose flagstone on the inside of our pond because it's a smoother rock, which means better flow throughout our pond and better efficiency. We chose limestone boulders on the outside of our pond because to add to our depth and appearance, and limestone boulders naturally get rid of acidity in a pond, which will help with that. We will also have fake rocks on the south side of our pond with solar panels on the outside for better energy efficiency. To get our tons of rock, we did length times width, which is 14 by 9 divided by 40 to give us 3.15 tons of rock.
The experiments we did were to find an alternative for the ice melt that we currently use because it's destroying the grass and we don't want that in our pond. So we conducted experiments with the ice melt that we currently use, sawdust, vinegar, and pencil shavings. And what we realized is that none of these options work. The ice melt obviously kills the grass, and the sawdust doesn't melt the ice fast enough. The vinegar melts it so fast that it would just freeze over again, and the pencil shavings. We talked to our janitors at our school and they told us about this alternative that's also a fertilizer. It's called urea, and it's organic and it's made out of nitrogen, and so it melts the ice, but it also won't kill the grass. but we have to have something to absorb that extra nitrogen, which Ellen will.
So, in Omaha, we're located in Zone 5. A zone is the level of tolerance your plants have for the heat and cold. So we've carefully selected a list of plants to go into our ponds. We have everything from black-eyed Susans to Columnar arborvitae, bleeding hearts, blazing stars, and prairie grasses. So to complement that urea, we're adding hydrangeas and azaleas because they are acid-loving and they will soak up all of that nitrogen and
For our last, we originally had three original options. Our first option was a small battery-powered double-sized light that will be able to move around with water but won't get stuck in the skimmer or filter. The bad thing about these lights is that since they're battery-powered, if the battery loses power, then we'll have to manually take them out and change the batteries. For our second lights, they are a 16-foot, 6-inch long strip of lighting that has an adhesive tape on the back so we'll be able to place it right under the water, and it can be solar powered, and if needed it can be plugged into a wall outlet. For our third option of lights, there are a 16-foot, 3-inch long strip of lighting that is the ideal lighting for a pond because their IP is 68. The first number means that it is dust tight, and the second number means that it is water tight. Our lights are expected to have a 10-year lifespan, and we will need 210 watts per day to run from 5:30 p.m. to 7:30 a.m. or about 14 hours. Our liner, we chose a polythene pond liner that is 25 feet by 30 feet by 20 millimeters. We will have to cut it to the shape of the pond, and it has a 20-year warranty.
Freezing is a big problem in Omaha. The record low is -32 degrees. So to prevent this, we'll submerge the pipes nearly 2 feet. We will also keep the water constantly moving. We calculated the average volume of the pond will be roughly 1,000 gallons. We found this by multiplying the length, width, and depth, which will give us our cubic feet, but then we multiply it by 7.48 to convert it to gallons. Now the goal is to circulate all the water in the pond 3 times an hour. Then we also have to think about the freeze line, which is the depth that the pipes need to be in order to not freeze over and burst. So, and in Omaha, that depth is 27 inches. A problem that most people don't realize is the pressure created by the pipes, which can cause the pump not to be able to push the water out. So you take how much vertical feet the pipe has to go up, and the total length of the pipe, and for every vertical foot it has to go up equals another foot of head pressure. For every 10 feet that the pipe is, equals another foot. In total, we have 11 feet of head pressure. And so we came up with our little giant, which can pump 3,125 gallons per hour over 11 feet of head pressure. And for the pipes, we just chose a flexible PVC.
Filters are a necessary part of a waterfall. They prevent the water from clogging, or from the pipes from clogging and not flowing. Our selected skimmer will attach to the liner with an 8-inch gap to let the water through. The job of the skimmer is to catch all of the leaves and rocks that get into the water. Our selected filter will catch all of the little things in the water, purifying it. The skimmer will need to be occasionally cleaned, while the filter has a self-cleaning feature.
So we've chosen the Yeti 1250 as our solar generator. Going solar means that you have a lot less maintenance. So this generator will generate 1,200 watts per day, any more, and it will not work. Our runtime depends on the number of devices that you have plugged into the generator. In our case, we have the skimmer, which generates 12 watts per day. You have the lights, which generates 210 watts per day, and you have the pump, which generates 660 watts per day. To calculate the runtime, you would divide the storage capacity on the battery by the wattage of the power supply, and that would give you your hours.
Our Optima brand battery will hold all of the electricity that we are not using. It is a car battery that at max can hold 576 watts and works in 12 volts. We can also charge much faster than normal car batteries.
We were given a grant of $4,800 from the Omaha Schools Foundation to build this. Our hardest task as a group was to make sure that this pond was sustainable throughout the years and that this would be our only main spending. Our excavation was free because we will be doing the labor work, and we will, the dirt that we dig up from our pond will be used back into our waterfall. The rocks that we use are $660 per square ton, limestone being $440 per square ton, and flagstone being $220 per square ton. Our liner was $225. Our lights were $100. Our pump and pipe were $430. Our skimmer and filter were $700. And urea costs $19.99 per ton. So our solar panel was our biggest cost, costing us $1,400. And our battery cost us $245. Altogether, that's a total of $3,760 without urea. That is what we hope the pond will look like after we're done.
We were approached about having a legacy in front of our school. We believe that this waterfall will not only help the environment, but will be here for years, and for what people will remember the class of 2016 by. Thank you for your time. Are there any questions?
Could you guys introduce yourselves so you don't
I'm Sarah.
I'm Colin.
I'm Connor.
I'm Nathan.
I'm Lucy.
I'm Zafira.
I'm Eleanor.
I'm Stop.
Very good. I like the presentation, how you laid it out there. What was the source for your cost estimates? How did you come up with those?
What are the costs? Well, everyone just, when they looked up, like what they were getting, they just gave me the prices that they were at, and I calculated how much we would need with our pond. So that's how I got it.
So did you go out like onto the internet or online to?
Yeah.
look up
Yeah,
And
prices
they
and things?
researched which ones seemed best fit for.
We looked at multiple different products and
And we talked to some professionals too.
How did your team work? Did you break up into sub-teams and have different areas?
each of us sort of had our own role. And for example, I'm the plumber and the pumps and.
That's
I think-
mechanical engineering.
Yes.
A lot of us work together, like me and Eleanor work together on finding the urea. We were a part of that. Why we talked to the vendors, and we conducted all the experiments along with Spray MC. And Nathan and Connor kind of teamed up because their things are similar, and so that's how that kind of worked and came together in the end.
And I want to add something to Sarah's statement. So when we were on our mission to figure out urea, we emailed somebody named Mr. Mark Warnke out at OPS or at the Tech Building, and so he was kind of on our side, and he was a great help. And we hoped that this will replace our Hilliard ice melt, which is currently being used.
And just yesterday, they had a meeting about the problem of runoff in OPS, and so they talked about finding an alternative, and Mr. Muscle informed us of that, and so we're very grateful that this has been taken into consideration.
So you had mentioned you received a grant to help kind of pay for this?
Yes.
So I just had a couple questions. One, did you guys help fill out the grant application, or was that done prior to you guys getting involved?
That was prior.
That was prior.
Yes.
The second question is you identified about $3,800 in costs, and you have a grant that's worth $4,800. Did you consider what improvement costs might be required? Let's say 3 or 4 years down the road, could something break down, or would you have to maintain things, or
Yes,
Clean
that's
things that
why
you
we
could
have
use
our
those
extra
additional funds.
1,000, and actually they're working on another grant, which is an extra $2,000, down the road for extra costs.
And then one last question, if they weren't able to get the urea and it was back to good rock salt, do you think that would affect your pond area? Did you kind of give any thought to that? It would be
I wanna,
helpful,
I wanna grab that really quick. Okay.
I knew you would.
So that's a fantastic question. So yes, we have considered that, and that would be, we would go back and we would research a little bit more, but as far as we know, dead grass would not be the end of the world, but it's certainly a big factor for us. So again, we would go back and we'd research and
Thank you.
So when you were doing the research about the different kinds of plants, was it surprising that different plants like different kind of soil or would absorb different kind of chemicals? Was that new and surprising to you?
And how much time is that and weather?
And figuring out which ones worked well together was hard, and doing it the work that we wanted.
Good. So what was the most surprising thing that you found while you were working on this project?
That you really have to work together. Like, that you can't be by yourself, you can't have your own opinion, you can have your own opinion, but everyone else has to agree. And so, I think for me, the hardest part was, like, I can't tell everyone what I want it to be. I can't do that, like, I have to take into people other considerations, I think is, you can't just be by yourself, you can't do by yourself.
And that waterfalls take a lot more work than we first expected, so, yeah.
So, a quick question, so I appreciate being an engineer, I appreciate the amount of detail that you went into and all the calculations for all parts and pieces of the system. One of the things in the report you mentioned on the solar panel side that you're gonna use rock solar panels. It looks like a change kind of direction on that. What drove you to change to the alternative that you presented here?
So we researched more, and that's a great question. We researched more and more, and we figured out that if you were to shield the solar panel, you would have no sunlight coming in. I'm sure that there probably is a solar panel rock out there. We would just need to find it. Great question.
You're all eighth graders, have you ever done anything like this before?
No. It was a new experience, definitely.
Would you like to do it again?
Yeah, it was a lot of fun.
How many of you knew something about engineering or architecture or landscaping before you started this?
We all did.
We all
We
did.
all
We
take
took
art
some
classes.
class.
That's
Okay,
where we
Do you have any questions for us about engineering or anything like that?
Does it ever get boring?
No, I'll answer for myself. I work with a couple of these fine gentlemen, and it's always very interesting. It's problem solving and doing research, and sometimes the problem solving is with technology, and sometimes problem solving is with your coworkers.
It's always pretty exciting. One of the neat things is getting to meet people. I mean, I've known John for 20 years, and just today, I got an email from a colleague wanting some information from the Corps. And so I asked John who was the right guy to contact, and John told me, and I sent the guy an email quick. And so, you know, it's kind of fun to get to know people and work together to find a solution with you guys. It's kind of fun.
Actually, I have a question. So, this is an engineering, landscaping, architecture project. What do you guys do on a daily basis, since you guys are like our role models now? Since you guys are engineers, what do you do?
Water resources engineering, we're the Corps of engineers. We do flood control projects, dams, levees, channels. We do an environmental restoration program. We fish habitat back in the Missouri River that was lost. We're right now getting into some work in Southeast Asia. It's more of a capacity building. We're teaching engineers in Laos and Cambodia how to do work. I've worked in 48 of the 50 states in about 7 countries.
do very similar work that John does. We're just wrapping up a project not far from here. It was the stream bank up the Little Plain Creek was sloughing a little bit, right across from UNO's Baxter Arena. And so we worked with the Corps and applied some of their standards to stabilize that stream slope. So it looks really nice. The people that constructed it did a really nice job. So if you want a little diversion on your way back to school, just go over by Baxter Arena and you'll see some of the stream bank. It's doctored up a little bit. It's kind of nice.
So one of the projects that I'm working on is with Sarpy County, which is just south of here. All the development is coming from Omaha and going south, but the way the land drains, it all drains to the south. But the wastewater treatment plant, there's not anything down in the southern part of Sarpy County to clean the water. So we're working with Sarpy County and all of the communities like Gretna and Springfield to help them try to come up with a solution to build a new wastewater treatment plant down somewhere in South Sarpy County.
I think more broadly to your question, what do we do? My fortunate experience has been with a lot of different projects. Right now, it's working with the CSO program, downtown. Well, you've heard that, the combined sewer overflow program. But on a daily basis, one day you may be doing calculations and writing something, and the other day you may be meeting with a bunch of clients to come up with solutions. It's different. Really ends up being different every day. It's a great career because it gives you a variety of things to do, so you're never really bored.
You think really hard for really long time sometimes.
Yeah.
We have to learn how to work together, as you mentioned, because you can't all have your way. You've got to figure out how to come together and go forward with the best answer.
So I think whether you decide, engineering, architecture, or whatever career you decide to go into, I think one of the takeaways is that you'll realize that if you have a technical problem that you have to solve, you spend a lot of time working on the technical problem, but there's also getting buy-in and getting your team to support it, to get your stakeholders to support it, whether it be, the citizens of Omaha or the people in Cambodia. So there's kind of two different parts of solving the problem, coming up with a technical solution, then also getting it actually implemented.
And to that too, one of the great things about engineering, if you go on to study engineering, get an engineering degree and pursue that career, or if you don't, an engineering degree sets you up to really do a lot of different things, even if it's not engineering. So.
You guys did a great job.
Thank you.
Thank you very much, Susan. Thank you very much.